Welcome to one of the most inhospitable places in the solar system. This is Mercury, named after the Roman messenger god for good reason. It's the fastest planet in our cosmic neighborhood. Mercury is the smallest and closest planet to the Sun, a world of violent extremes that challenges everything we think we know about planetary survival. At just 58 million kilometers from the Sun on average, Mercury holds the inside track in our solar system's cosmic race. But don't let its small size fool you. This world holds secrets that could rewrite our understanding of planetary formation. Mercury is barely larger than our moon, yet it's the second densest planet in the solar system. This tells us something profound about what lies beneath its battered surface. Unlike Earth, Venus, or Mars, Mercury is essentially a giant ball of metal wrapped in a thin, rocky shell. Its iron core makes up an astounding 85% of the planet's radius. The name Mercury fits perfectly. Just as the Roman god was the swift messenger between worlds, this planet races around the Sun faster than any other. Forget the 365 days we're used to. On Mercury, a year, one complete trip around the Sun, lasts just 88 Earth days. If you lived there, you'd celebrate New Year's every 3 months. Mercury's orbit isn't a perfect circle. It's the most eccentric of all planets, swinging between 46 million kilometers and 70 million kilometers from the Sun. This proximity to the Sun means Mercury hurtles through space at 47 kilometers per second. That's 170,000 kilometers per hour, making it the undisputed speed champion of the solar system. Here's where things get truly strange. Mercury is tidally locked in a peculiar 3-to-2 resonance with the Sun. It rotates exactly 3 times for every 2 orbits around the Sun. The result? A single day on Mercury, from one sunrise to the next, lasts 176 Earth days. Think about that. A day on Mercury is twice as long as its year. From Mercury's surface, you'd witness something impossible on Earth. The Sun would appear to stop in the sky, move backward briefly, then resume its forward motion. A truly alien sunrise. During Mercury's long day, surface temperatures soar to a blistering 430 degrees Celsius, 800 degrees Fahrenheit. That's hot enough to melt lead and tin. The rocks themselves would glow with a dull red heat. Any astronaut standing on the sunlit side without unimaginable protection would be incinerated instantly. This is the direct result of Mercury's proximity to the Sun and its lack of protective atmosphere. With no atmosphere to distribute the energy, all that solar heat arrives, bakes the surface, and then escapes just as quickly when night falls. But when the long day gives way to equally long night, the situation reverses dramatically. With no atmosphere to trap heat, temperatures plummet to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. This gives Mercury one of the largest temperature swings in the solar system, over 600 degrees Celsius difference between day and night. It's cosmic whiplash on a planetary scale. Yet in a stunning paradox, scientists have found water ice on Mercury, hidden in permanently shadowed craters near the poles where temperatures remain stable enough for ice to persist for billions of years. Mercury has virtually no atmosphere. Instead, it possesses what scientists call a surface-bound exosphere. It's so thin that molecules are more likely to collide with the planet's surface than with each other. This ghostly shroud consists of oxygen, sodium, hydrogen, helium, and potassium, atoms literally blasted from the surface by solar radiation and micrometeoroid impacts. The sodium atoms are pushed by sunlight into a long, comet-like tail that streams millions of kilometers into space, a visible sign of the planet's continuous interaction with its harsh solar environment. This exosphere is not stable. It's constantly being replenished from the surface and lost to space simultaneously. The Sun acts like a cosmic sandblaster, constantly scouring Mercury's surface. The pressure at Mercury's surface is about 1/4,000th of Earth's sea level pressure. You could call it a vacuum, and you wouldn't be far off. By analyzing the atoms floating above Mercury, scientists can learn what the rocks below are made of without even landing there, a form of remote sensing geochemistry. Look at Mercury's surface and you're seeing a cosmic history book. Like our moon, it's heavily pockmarked with impact craters, the result of billions of years of bombardment by asteroids and comets. With no atmosphere to burn up incoming projectiles and no geological activity to erase the evidence, every impact is preserved. It's a museum of cosmic collisions frozen in time. The craters range from small, fresh-looking bowls to ancient degraded basins hundreds of kilometers across. Many have bright rays of ejected material extending outward like frozen splash marks. Among these countless scars, one feature stands out. the Caloris Basin. This colossal crater stretches 1,550 kilometers in diameter. It's so big you could fit the entire state of Texas inside it. Caloris was formed by a cataclysmic impact with a planet-sized asteroid early in Mercury's history. The collision was so powerful it sent seismic waves reverberating through the entire planet. The impact was so immense it created bizarre, jumbled landscape on the exact opposite side of the planet, the aptly named Weird Terrain, where the seismic waves converged and shattered the crust. Deep beneath Mercury's battered crust lies one of its greatest mysteries, a heart of metal. Mercury's iron core makes up 85% of the planet's radius, compared to Earth's core at just 55%. Mercury is the second densest planet in the solar system after Earth. For such a small world to be so massive, it must contain an unusually large and heavy metallic core. How did Mercury get such a disproportionately large core? Scientists have theories. Perhaps a colossal impact stripped away its original crust and mantle, or intense solar heat vaporized the lighter elements during formation. This huge, partially molten core has a fascinating consequence. Mercury generates a magnetic field. It's weak, only about 1% as strong as Earth's, but the fact that it exists at all is remarkable. Planetary magnetic fields are generated by a dynamo effect. Molten, electrically conductive material moving in a planet's core. But Mercury rotates very slowly, which should make a dynamo difficult to sustain. This weak magnetic field carves out a small bubble in space around Mercury, deflecting the solar wind and providing some protection from charged particles, especially near the equator. Why study this small, hostile world? Mercury is a scientific treasure trove, a natural laboratory for testing our theories about planetary formation and evolution in extreme environments. Its disproportionately large iron core challenges our models and forces us to reconsider the chaotic nature of the early solar system. How do planets form and survive so close to a star's immense gravity and radiation? Mercury's ancient, heavily cratered surface acts as a cosmic archive, preserving a pristine record of the bombardment that all inner planets endured during the late heavy bombardment 4 billion years ago. Sending a spacecraft to Mercury is one of the most difficult feats in planetary exploration. It's not easy to fall toward the sun. Probes must shed enormous orbital velocity through complex gravity assist maneuvers. Once there, spacecraft face radiation up to 11 times more intense than Earth orbit, temperatures hot enough to melt electronics, and the constant gravitational tug-of-war with the sun. Survival requires sophisticated sun shields made of heat-resistant materials, keeping sensitive instruments at room temperature, while the shield's front face endures furnace-like conditions. Humanity's quest to unveil Mercury's secrets began with NASA's Mariner 10, launched in 1973. It was a trailblazer, the first spacecraft to visit 2 planets and use gravity-assist maneuvers. During 3 daring flybys, Mariner 10 mapped 45% of Mercury's surface, revealing its moon-like terrain and discovering its unexpected magnetic field for the first time. For more than 30 years, Mariner 10's images were all we had. Mercury remained a world of mystery, half in shadow, waiting for the next visitor. That changed with NASA's Messenger mission, launched in 2004. After a complex 7-year journey including 6 planetary flybys, it became the first spacecraft to orbit Mercury in 2011. For 4 years, Messenger revolutionized our understanding, mapping the entire surface in high resolution, confirming water ice in polar craters, and revealing Mercury's surprising composition. In 2015, after exhausting its fuel, Messenger ended in a planned crash, adding one final human-made crater to Mercury's ancient surface, a fitting resting place for a historic explorer. Today, a new chapter is being written by Bepi Colombo, a joint mission between the European Space Agency and Japan. Launched in 2018, it consists of 2 orbiters for unprecedented detailed study. Currently on its complex journey, Bepi Colombo is scheduled to enter Mercury orbit in late 2025, promising to delve even deeper into the mysteries of Mercury's iron heart and magnetic field. Bepi Colombo will build on the legacy of its predecessors, seeking answers about Mercury's formation at the dawn of the solar system and its role in our cosmic neighborhood. Mercury, the swift messenger, remains one of the most compelling and enigmatic worlds in our solar system. It is a planet of stark contrasts and profound extremes, a world scorched by unimaginable heat yet harboring frozen water, where a day lasts longer than a year, and where a tiny planet possesses a gigantic iron heart that generates a mysterious magnetic field. This hostile environment makes Mercury crucial for scientific inquiry. It pushes our theories to their limits and forces us to ask fundamental questions about planetary formation and survival. The challenges of exploring Mercury are immense, making every mission a triumph of human ingenuity. Robotic emissaries brave conditions we could never endure to expand our cosmic perspective. Mercury reminds us that exploration isn't always about finding new homes, but about understanding our own origins. It's a key to the grand narrative of our solar system. Mercury stands as a resilient explorer, perpetually circling its star, enduring the harshest conditions the cosmos can offer. By studying this dynamic world, we learn about planetary formation, stellar behavior, and our own place in the universe. Mercury's story is a vital chapter in the much larger story of us, and it's a story we've only just begun to read.